Oh, yeah, mine was
On the test?
On the, homework,
Yeah.
that's the only one I don't have, cause
Like
that,
question 18 or
something like that. 2.1, number 24? We'll look at it.
I'll have, I won't have it on my notebook.
Girl,
I'm telling you.
what in the world? Alright, so we are dwindling down. Today, I think I have like 5 pages left. Today, we are finishing up Unit 6, I only have like 5 pages left. Then we're gonna start reviewing for the exam, and then on Thursday, I'll spend the whole class period reviewing for the exam. Your test, Lou, your test is due tonight, that's your take-home test. 4 people have submitted it so far. We still have the rest of y'all that are gonna submit it by 11:59 tonight. Homework is due tomorrow at midnight. Your, exam is a week from Thursday, 9:30 to 11:30, a week from Thursday. And that's it, we're done. So 1 week and 2 days is all we have left.
Do we come to class on the 4th?
No, you do not. So you will see me today, you will see me Thursday, and you will see me the following Thursday. That's it. You do not come to me on Tuesday. So, gosh, when we left last time, we were talking about central limit theorem, and we said if you have a single piece of data versus group data. And I'm going to do a couple more problems. The only difference was we did shading to the left, shading to the right, mean, standard deviation. The only difference was for standard deviation, if it's a single piece of data, standard deviation, it is what it is. If it's group data, your standard deviation is going to be the old deviation divided by the square root of the size of the group. That was the only difference. And I'm going to do a couple problems just to remind us what we were doing. This one says, and let me make it a little bit bigger. This one's actually a cool problem. Say that about every single one of them. Get some water. Quarters are now manufactured so they have an average weight of 5.67 grams and a standard deviation of 0.062 grams. And their weights are normally distributed. A vending machine is configured to accept quarters that weigh between 5.55 and 5.79. So, first thing I'm going to do is I'm going to draw me a cute little picture. So, we have a normal distribution. We have a mean of 5.67. Down just a hair. We have a standard deviation of 0.062. And my data points are 5.55, which would be to the left, and 5.79, which would be to the right. And it's saying that quarters that weigh between those are good quarters. So if your quarter weighs less than 5.55 or more than 5.77, the machine's going to kick it out. So if it's got a piece of gum on it, or if it's chipped and been run over, it's going to kick it out. But as long as it weighs between that, we're good to go. Yay? Now, it says, the first one says, one randomly selected quarter. That means that this is single data. That means your standard deviation is what it is. So because we're doing the guts, the probability, the inside, are we doing normal CDF or are we doing inverse norm? So we're going to do normal CDF, left, right, mean, standard deviation. So what is my left? 5.55. What is my right? 5.79, what is my mean? 5.67, and what is my standard deviation? 0.062. I'll move it over so I won't be on the edge of, oh. Let me grab all of that, so I will be still missing that. Just gonna move it down and over. So I'm gonna go to my calculator. Second bars. Normal CDF. And remember on your test, I'm gonna let you use your own calculator, and I'll bring in some, and you can also use the ones on the computer. In the testing room, they'll look like this, but in here, I'll let you use whatever. So this is gonna be my first answer. Yay? Now, for the next one, it says 4 randomly selected quarters. That means this is group data. So for this problem, your standard deviation is going to be different. So, here's the easiest way to show you. I'm going to grab my little camera. It'll let me grab it. There we go. Same exact problem, y'all. I'm grabbing the camera and I am pulling this over. So, my left is still the same. My right is still the same. This is still the same. The only difference now is that my standard deviation is going to be the old standard deviation divided by the square root of how many people are in the group. So my old standard deviation is 0.062. We're going to divide that by the square root of 4. That's the only difference. So if you have group data, you take the single data and divide the last piece by the square root of the group. That's the only difference. So when I go back to my calculator, watch what I'm going to do. Second enter recalls the problem. I back that thing up and I divide by the square root of 4. There's your answer. So single data and group data, so all I just did is I made my standard deviation skinnier. That's all I did. So this is the answer to part A. This is the answer to part B. So part A, your standard deviation is 0.062. Part B, your standard deviation is 0.062 divided by the square root of 4. Because your standard deviation is skinnier because you've got several people in the picture. Now, if you own a vending machine, which is more important, A or B? Is it more important that you worry about one quarter, or is it more important that you worry about a group of quarters? Okay, 1 quarter. Because I care about each individual quarter going in there, because that's money to me. So this one is going to be, part A is more important because I want to make sure each quarter works. That's money in my pocket. Yay? So group data is the same as single data, except you've got to divide the last piece by the square root of the group. That's the only difference. I'll do another one. I can totally see me doing this next problem. When I have my husband, I don't drink any caffeine at all. And so when I have my husband go into the store to get me a water or a lemonade, I always say, get the one that's the fullest. If you look, now in cans you can't tell, but in bottles, some are a little bit fuller than others. And so this is saying I went and got some cans of Coke. Now on the can it says there's 12 ounces. So there's a normal distribution with a mean of 12 and a standard deviation of 0.11. Now, what they did is they went and got some Coke cans and they actually measured each individual one of them. This one may have had 12, this one may have had 12.1 ounces. This one may have had 11.98 ounces. This one may have had 12.2 ounces. You know, did they have exactly 12? Am I being cheated or am I being, given too much? So, first thing I do is I draw my cute little picture. We have a normal distribution. 12 is our mean. Our standard deviation is 0.11. Okay? Now, for part A, a single can of Coke. So that is individual data. Okay? That the can has at least 12.19 ounces. So 12.19 is my data point. So am I shading to the left or am I shading to the right of that point? To the right, because I always say if you have at least $5 in your pocket, does that mean you have less than $5 or more than $5? If you have at least $5, that means you have 5 or more. So if you have at least 12.19, that means you have 12.19 or more. So at least means or more. Yay? So because I'm finding the probability, because I'm finding the shading, I'm going to do normal, CDF, the left, the right, the mean, and the standard deviation. And because it's single data, if you take a picture of me, I am what I am. The numbers are what they are. So what is my left? 12.19. What is my right? 9.99. What is my mean? 12. And what is my standard deviation? 0.11. So my left is 12.19. My right is 9.99. My mean is 12 and my standard deviation is 0.11. Now, I'll plug it in the calculator in just a minute. But the next problem says we have 36 cans of Coke. So this one is group data. So we just put 36 cans in a picture and said, hey, pose for the picture. Everybody's going to look skinny now. So what we're going to do is we're going to take this problem, clone, and I'm going to call this part B. And because it's group data, I'm going to divide the last piece by the square root of 36. That is the only difference between individual and group. So to get the first answer, I'm going to do second enter. I'm just going to get rid of all of this.
Question.
Yeah.
So you wouldn't make the left -999?
Because we're headed this way, that's in the positive direction.
Okay.
So that one's positive 999. Had it been drawn like that, that would have been negative 999 to, let's say, 11.
Okay.
So if you're going that way, it's a negative 999, and if you're going to the right, it's a positive 999, just like on the number line. Does that make sense?
Yeah.
And if the point is to the right, and this is not or more, this is like the biggest number. It's supposed to be negative 999 and the big number the right.
Correct. So this one's going to be 12.19, comma, 999. Hold on. 12.19, comma, 999, comma, 12, comma, .11. So that would be my individual data. And then I'm gonna do second enter, because I'm too lazy to type it. I have that .11, I'm just gonna divide by the square root of 36. There's no need for me to calculate that. Now, look at that second answer, y'all. My first answer for part A, my first answer is gonna be .042059, or 4.2059%, yay? Tell me about my second answer. What's my second answer?
1.85 is going at -25.
So what does that mean?
A lot of zeros.
A lot of zeros. So if you pay attention to this big thing in the back, right here, that means move your decimal 25 times, so it's .000000000000000, then 1853. So what's the answer to the second one? And what a lot of people do is they don't even look, they just say, oh, the answer is 1.8534, or whatever. The answer is really 0, or 0.0000, however they want it, but it's 0. If you have 0.00000, if the probability of you being the daddy is 0.00000000000, it ain't gonna happen. You're not the daddy. We good? I heard this morning on TV that Maury Povich is now doing a new show where he's a judge. Yeah. That's the newest show. Heard it this morning. Hadn't seen it on Facebook yet, but I heard it this morning on the radio. All right, so that's the end of whatever section I was just on. That's the difference between single data and group data. Now, this last section is called confidence intervals. Now, very first day of class, we talked about y'all were the sample, and Florence Arlington Tech was the population. And if I want to go from y'all to the population, from the sample to the population, we can do something called the 95% confidence interval. And what we do is we take y'all's average, and we find the margin of error, and we wiggle off of it. So if I said 75% of y'all have a phone, and the margin of error is 5%, I would do 75% of y'all have a phone, and I would wiggle 5% in either direction. So if I give you an example and say 75% of my class has a phone, and the margin of error is 5%. Then I would take 75%, which is my class, the sample, and I would wiggle 5% in either direction. So 75% plus 5% would give me 80. 75% minus 5% would give me 70. So that my 95% confidence interval would be 70% to 80%. And I would say that I am 95% confident that the population has a phone. So, if 75% of this class has a phone, with the 5% margin of error, then I would be confident that 70 to 80% of the school has a cell phone. So what I'm doing is I'm taking y'all's average and I'm wiggling in either direction, that's called my margin of error, and I'm coming up with these two numbers, and that is called my confidence interval. So I'm taking y'all's data, wiggling, and that's giving my confidence interval for the population. This is the last little bit that we're doing. I'm wiggling off the mean to find the confidence interval. Now, there is a formula for margin of error, and it's on your formula sheet. Okay, this is on formula sheet. It says that the error equals 2 times the standard deviation over the square root of the number of pieces of data. So E is approximately 2 times S, which is our standard deviation, divided by the square root of how many pieces of data we have. So 2 times standard deviation divided by the square root of N, which is how many pieces of data we have. That's going to give me my error. That's going to tell me what this number is. And once we get that number, we added and subtracted off the mean, off the average.
Can you go back over just a second?
I can do whatever you want to.
I was talking about that last one.
So we're going to have to calculate the error, and then once we calculate the error, we're going to wiggle off the mean, and that's going to give us our population. I'm going to do a problem. It's not as bad as it looks, I promise. Not as bad as it looks. Okay, so for this one, I have 49 people in my class. The average head size, let's say, is 25.2. The sample standard deviation is 2.2, and it says find the margin of error and find the confidence interval. So the first thing they want us to do is find the margin of error. And then the second thing they want us to do is find the confidence interval. Okay, now just a second ago I gave you the formula. It says E equals 2S over the square root of N. E equals, the error equals 2 times S over the square root of N. So I'm going to do 2 times what? 2.2 divided by the square root of 49. So I'm going to come over here to my calculator, and I'm going to do 2 times 2.2 and divide it by the square root of 49. Now, my math lab is going to tell you where to round it to. I'm just going to call it 0.629. They'll tell you how many places to go. I just went through. So that's my error. That's my wiggle room. That's what I'm going left and right. Now, what do I wiggle off of? Yes. I wiggle off of the mean. So I take the mean and I add the error, and then I take the mean and I subtract the error. So my mean is 25.2, and I'm going to add the 0.629, and I'm going to subtract the 0.629. So I'm going to come off to the side, and I'm going to take my mean, 25.2, and I'm going to add the error, and I'm going to take the 25.2, and I'm going to subtract the error. So my confidence interval is going to be from 24.571 to 25.829. So the first thing we had to do was find the error, and after we find the error, we wiggle off the average, the mean. And that's going to give you, and your confidence interval always goes from the smaller number to the bigger number. That one's not that bad. And that error formula is given to you on your formula sheet. So if the class had a head size of 25.2, we figured out where the error is. So I could be confident to tell you, if I go out in the world, I will be 95% confident that I will walk up to any person and their head size will be between this and this. Not that I would do it. All right, now, same thing, it says give me the margin of error and the 95% confidence interval. Okay, So first thing I want to do is I want to find my error. 2 times the standard deviation divided by the square root of the size of the group. So I'm going to do 2 times what? 3.1 divided by the square root of 81. 2 times 3.1 divided by the square root of 81. And what am I going to wiggle off of? So this is my error. My margin of error. What am I wiggling off of? 4.5. Now, they wrote it kind of different. I'm going to take my mean plus, no, that would be a minus. My mean minus my error, and my mean plus my error. And this is saying that my average, my population average, my population mean is going to be between. So my population average, so if my sample average is this, then my population average is going to be between that and that. So that is my confidence interval. So this is called my confidence interval. Cool? Mean plus the error, mean minus the error.
Homework's
And like I said, Alex will tell you what they want you to round it to. And I did several of these. They're all the same thing. This is the number of people. This is your mean. This is your standard deviation. So I did 2 times your standard deviation divided by the square root of that. So this is going to be my error. And what am I wiggling my error off of? Which is 8. So I'm going to do 8 plus 0.4 and 8 minus 0.4. 8 minus 0.4, 8 plus 0.4. Y'all with me? And then I did another one right here. I'll have all of these out here. And I did 2 times the standard deviation divided by the square root of the number, gave me my error. And then the mean plus 15, the mean minus 15. Cool? All right, last thing that we're going to talk about is, hold on, let me see what this is. This one's a good one. We go to a neighborhood, and in the neighborhood there's 62 houses. The average weight of people who discard plastic is 1.91 pounds. Standard deviation is 1.07. Use a single value to estimate the mean. Also, I want you to find the 95% confidence interval. Okay? So, in order to find the 95% confidence interval, we first need to know the error. So error equals 2 times standard deviation divided by the square root of the size of the group. So 2 times what? 1.07 divided by square root of 62. So that is going to give me my margin of error. Now they didn't ask me for margin of error. They didn't say what is margin of error. But in order to get confidence interval, you have to know the margin of error. So I'm going to do 2 times 1.07 divided by the square root of 62. That's my margin of error. Now, what am I wiggling off of? You're going to wiggle off the mean. So my mean plus my error and my mean minus my error. Sound like I'm saying arrow. So it's going to be 1.91 plus the 0.272 and minus the 0.272. Okay? Now, there's also another question that says use a single value to estimate the mean. What's the mean of this problem? The mean is the mean is the mean no matter what. The mean is always 1.91, no matter whether it's group data, single data, multiple data, no matter what the data is, the mean is the mean is the mean. So, I kind of worked it out down here. Cover this, uncover this.